Welcome to Simplifying Radicals. We are doing this before section 6.2 so that we're prepared for the quadratic formula. Let's go to work. I'm going to do the even problems as always. Okay. Remember, simplifying a radical, there's two ways to do it. One is to take the perfect square, and I'll do each of the two different ways. But one is to take the largest perfect square. Remember, our perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225. That's just the first 15 of them. Okay, so one way we can do this is say, hey, what's the largest perfect square that go into 80? Well, 4 obviously goes into 80, but the 16, 32, 48, 64, 80, yeah. 16 goes in. So I could rewrite this as the square root of 16 times, what, 5? Yeah, 16 times 5. And then that rewrites as a square root of 16 times the square root of 5. And since we know 16 is a perfect square, that then means 4, because 4 is the square root of 16, times the square root of 5. And that's your simplified version of the square root of 80. That is called simplifying a radical. Now, that's one way to do it. The other way is to use a factor tree. Okay, and a factor tree is where you just write down the factors. What times what gets me 27? Well, 3 times 9. Well, that's a prime number. We're going to keep working these down until we get all prime numbers. 3 times 3 is 9. So we end up with, anytime that two of these appear together or they're doubled up, that can be pulled on the outside. So we're left with 3 times the square root of 3. And that's the simplified version of that. That one wasn't very clear, so let me do it again. So when I'm doing this factor tree, I'm looking for doubles. So let's try 45. Well, 45 could be 3 times 15, right? And then 15, well, 3 is prime, but 15 breaks up into 3 times 5. Now you see how there's 2 3s? Since there's 2 of them, I put that on the outside. And when there's only one of them, I put it on the inside. So 3 times the square root of 5, and that's using the factor tree. Now, number 8, I like number 8 because number 8 is one of my perfect squares. That makes it pretty easy. The square root of 100 is 10. Now, what happens when I have variables? Okay, let me do the number first. Let's go 90. Let me factor tree that to 9 times 10, and 3 times 3, 2 times 5. Well, I've got 2 3s, so I can pull that out. And then the 2 and the 5, they're just singles, so I'm going to leave it right there. 3 times the square root of 10. Okay, now, the other thing that happens is we got to look at this variable. Okay, and since it's a 3, basically I end up with 3, and I want to take the square root of that. So I could rewrite this as n squared times n. That gets me, that gets me 3 n's, right? And if I take the square root of each of those, I can take the square root of a square, and that pulls out an n. And this one, since it doesn't go in evenly, I just leave it in there. So I have n times the square root of n. So this ends up being 3n times 10n, the square root of 10n. Since that was clear as mud, let's try it again. Let's start with the 300. I want to go back and do it by using the perfect squares, because I can break this up to be 100 times 3, right? And then the n's, I could break it up to be n squared times n squared. Now, why did I choose those values? I chose this one because it's a perfect square. And anytime that I have an even power, that's a perfect square too. So when I take the square root of perfect squares, which is this one, and this one, they can come out to the outside. Well, square, and another way I could write 10 would be 10 squared, right? So what's the square root of 10 squared? Well, I can pull out the 10. What's the square root of n squared? Well, it's n. What's the square root of n squared? Well, it's n. So I have 10nn. Well, I wouldn't write nn, would I? No, that's 10n squared on the outside times the square root of 3. That is the simplified version of 300n to the fourth. I know. Some of you are like, that doesn't seem easier. It takes some time to get the hang of simplifying radicals. Okay. So let's start with a cubed over here, just 4. I could rewrite that as a squared times a, right? And if I take the square root of a squared, it becomes a. So that can be on the outside of the radical. And this one, I can't, that doesn't go in there. There's no power up there. So I just kind of got to leave that one as it is. So that's going to stay on the inside. So I'm going to have a on the outside and a on the inside of the square of the radical. Now 256. Well, it's even, so I know 2 goes into it. 2 goes in 124 times. 2 goes into that 62 times. 2 goes into that 31 times. 31. I don't think anything goes into 31. So I'm left with 2 2s, which means I can pull one of those out. And since 2 and 31 are sitting there by themselves, I'm going to leave that there. So that 62 goes on the edge. So that's 2a times the square root of 62a. Cool? Cool. All right. Moving on. Number 16. So that get it out of our way. Okay, so 243. Let's prime factor tree it. What goes into it? Well, 3 goes in. 3 goes in 81 times. 81 could be 9 times 9, right? 9 is 3 times 3. So I got 1 3, 2 3s on the outside. Well, so I got 3 times 3. All right. And I've got 1 3 inside. That one goes inside. All right, so what about m to the 5th? Okay. That could be m times m to the 4th. And then I can write m to the 4th as m squared times m squared. What's the square root of m squared? That's m, and that's an m. So I can pull those 2 m's outside, and this m stays inside with 3. And then m times m. Well, 3 times 3 is 9. M times m is m squared times 3m. Another way to think of that is take this thing, and how many times does 2 go into 5? Well, it goes in 2 with 1 left over. Another way you can think of it. So, all right, number 18, 392. 2 goes into it. Goes in 1, 9, 6. 2 goes into that. Goes in 96. 2 goes into that. 48. 2 goes into that. 24. 2 goes into that. 12 times. 2 goes into that. 6 times. 2 goes into that. 3 times. Okay. I've got 2, 2, 2, and a 2 and a 3 left. Okay, so on the inside, 2 times 3 is 6. On the outside, 2 times 2 is 4 times 2 is 8. I've got an 8 on the outside. All right, so this x is to the first power, so it's going to stay on the inside. This one divided by 2. 2 goes into it evenly twice, so I'm going to have a y squared. And 2 goes into that 1 time, so I'm going to have a z. So 8y squared z times the square root of 6x. Wow, we're having fun now. Okay. 128. Well, 2 goes into it. Goes in 64 times. 2 and 32. 2 and 16. 2 and 8. 2 and 4. 2 and 2. 1, 2, 3. 2 times 2 times 2 is 8. Times the square root. Oops, got some letters to deal with. Times the square root of 2. See, this one didn't have a pair or a matchup, so it goes on the inside. Okay. All right. 3 divided by 2 goes in 1 time, so I can pull out 1x, and there's 1x left over. Y is only 1, so it stays on the inside. 5 divided by 2. 2 goes in there 2 times, so I got z squared and 1 left over. So maybe that helps. There is simplifying radicals. Have a great day.